Okay, so the problem we're looking at today is the USACO 2019 December contest gold problem 1 of milk pumping. You can pause the video first and look at the problem statement yourself. Okay, I assume you read the problem. So a quick summary of this problem is, so you're given basically end conjunctions and end pipes, and now you're trying to connect point 1 and n with the maximum flow rate divided by the cost. So the end pipes are defined with a cost and a flow rate, and the minimum and the flow rate of a whole path is defined as the smallest flow rate of any pipe that's used in this path. And now you're trying to determine the maximized value of the flow rate divided by the cost. So you can now pause the video again and think about this problem yourself. Okay, I assume you thought about the problem. So what are some first things that we notice when we see this problem? So since the answer is not just one value, but is the result actually dividing two different variables, is going to be pretty complicated to find this answer directly. And the only way to do this is probably DP, right? Dynamic programming. And that is the first idea that I went with. So my idea at first is a DP where Fij represents the cost of connecting node 1 and I with the minimum flow rate of J. However, I noticed that this idea would not work because of this. If we have these points 1 to n, we can't really do this because we have to iterate through all the i's in a certain order. Let me write down the DP first. Fij equals 1 to I with the minimum flow rate of J, right? That's what my DP is, but I quickly realize it's not going to work because think about it. If we go from 1 first to here, and then we go back, we have another pipe that's connecting back, and then we go to n, like that. Well, then if we iterate through from 1 to this point, when we get to here, when we get to this point right here, we wouldn't have yet gotten the f value of this point, but this point is needed to find the f value of this point. So it's not going to be possible to DP in any order because we can have reverse going pipes. So what can we do now? Since we obviously can't just directly find the best value for this, what if we just get rid of one of these variables? What if we just enumerate the flow rate or the cost of the path? And we quickly find that enumerating the flow rate is way easier than enumerating the cost, as if we enumerate the minimum flow rate, we can just get rid of all the pipes with a flow rate less than the minimum that we just enumerated. And then we can just run a shortest path algorithm on it, right? So now this problem becomes super easy. You basically enumerate a number from the minimum flow rate given from all these pipes to the maximum flow rate given for all these pipes, and then for that flow rate you enumerated, you define that as the minimum flow rate that can possibly occur on this path from 1 to n, and then you run the shortest path algorithm while not using any of the pipes that have a flow rate of less than this minimum that we just enumerated. So here's my implementation of this algorithm. The shortest path I use is Digestra, and it's probably the best one, I would say. I mean, you can use SPFA, but problems at this time period probably already involve hacks that makes FPFA have a time complexity of n squared. So Digestra is the safest with time complexity of n log n. So first of all, of course, I store all the edges in the vector, and then this is enumerating the minimum flow rate. I solve using Digestra. While using Digestra, every single pipe with a flow rate of less than the minimum that we just enumerated is not used. And this will give us a time complexity of enumerating the pipe of the range of the flow times n log n for the n conjunctions. And if we take a look, the range of the flow is 1 to 1000. So we can pass this problem. So I hope after this video, you will understand how to do the USACO 2019 December contest gold problem 1 of milk pumping. Hope this video helped. Thanks for watching.